right, so looking at number 1 on ratios of perimeter and area, what we don't worry about is that those are cylinders. Yes, those are 3D figures, and no, we haven't had the 3D figure unit. You didn't just miss it. But all we care about is that they gave us the height of the cylinder. The height is like a side length. The height is a dimension of our cylinder, so height is one-dimensional. Find the ratio of the diameters. A diameter is a segment, just like a height is. So diameters are one-dimensional as well. So if the ratio of the heights is 5 to 8, the ratio of the diameters likewise is going to be 5 to 8. Does that mean that the diameters are 5 and 8? No. The diameters might be, well, honestly, the diameters have pi in them. They might be some crazy weird decimal times pi. It doesn't matter what the diameters are, but when you put them in ratio form and you reduce it, you get 5 to 8. Find the ratio of the surface areas. Here's where things change. Oops. So the ratio we've been given, 5 to 8, or 8 to 5, that's in one dimension. We want the ratio in 2D, so all we do is not worry about how to find the surface area of a cylinder. We square the 1D to get the two-dimensional ratio. You always want to make sure that you can't reduce it because you want it to be in final form. How do you get from 1D to 2D? You square it. Okay. Then part 3 is like, oh, okay, now actually use the ratio to solve for a missing side because that's what this is all about. Solve for missing things. The area of the base, okay, stop right there. When you see the word area, you know you're working in 2 dimensions. Centimeters squared, 2D. Find the area of the base of the larger cylinder. You don't care that the base is a circle. You don't need to use pi r squared and find the area of a circle. We'll save that for next unit. All you need to know is what dimension you're in. So I'm going to use one of my ratios. Am I going to use 5 to 8 or 25 to 64? Since I'm in 2D in problem 3, I'm going to use my 2D ratio so I don't have to do any adjusting. 25 is to 64 as, okay, the smaller cylinder. So if I'm wondering where to put 50, I put it where the smaller one went. And this is 2D. This is 2D. And when the ratios match dimensions, you're allowed to cross multiply. So when you cross multiply, that's when you get the missing area of the base, 128 centimeters squared. 15, very similar problem. We have 2 similar triangles. They gave us side lengths. Let's stop right there. Let's find the ratio with those side lengths. This time we'll do AB to DE. And you can keep it 18 to 3. Oops, sorry. Or you can put 6 to 1. Keep it 18 to 3, put 6 to 1. Totally up to you. There's no need to reduce it because your calculator can handle that. Okay, so we have to be careful. This is one-dimensional. Okay, 72. ABC went on top. There we go. That's much better. This is an example when they do not match. One of the columns is 1D and one of the columns is 2D. You cannot cross multiply. So instead, you need to square this one, and now everyone's happy. They all match. So we cross multiply 72 times 1 divided by 36. And that's how we get that the area of the triangle is a small 2 inches squared.